Well, good afternoon, Algebros. Here we are with our second semester study guide. It's just been such a great year. I appreciate each one of you. I'll be praying for you as you move on to the future. Always have office hours during lunch. If you find any challenges in math or anything else moving forward, or ever need to have somebody praying for you, or just need to have somebody listening, I'm there for you. Or you just want to come hang out and have lunch with your friends, whatever, okay? All right, here we go. Last study guide. So, number 1, in order to find the ordered pair, we have to know what an ordered pair is. It's an x and a y value. It's a specific point on a graph. Every linear equation is full of lots of solutions, which are points on a graph. And in this, we have one shared solution where they cross over. So of course that has an x value and a y value, just reminding us how we graph those points on a line. Number 2, we're going to solve this inequality. In order to solve this inequality, we would use SADMAP, right? We would use the inverse operation, starting with subtracting and adding, then multiplying, dividing, and whatever it takes to isolate our variable. So we add 5 to both sides, and then we would divide by 3, and we get x is greater than 4. The question here is, what are some solutions and what are some non-solutions? So solutions would be anything greater than 4. So starting with 5 and 6 and so forth. Non-solutions would be things that aren't greater than 4. So of course that would be 4, because 4 is not greater than 4, and 3 and 2 and 1, so forth. Number 3, when I look at the x and y intercepts of this equation, I have to remember that x intercepts are the horizontal, and if I want to find the x-intercept, I need to know that the y value would be 0. If I want to solve for the y-intercept, I would know that the x value would have to be 0, because it's just basic coordinates on the plane, right? Knowing that information, to solve this, I know I can have a t-table, and if I want the x-intercept, I put y as 0, and if I want the y-intercept, I put x as 0. So in the equation, when we substitute it in, we eliminate that y value to solve for x, getting x is 9. And to solve for y, we eliminate the x value, putting 0 in, and we solve for y. So the x-intercept is 9 and the y-intercept is -6. On number 4, we have a system and 4 points to see if any of these are solutions. So we check the first solution in here, we substitute the values in, and we see if it's true or false. -5, is it that greater or equal to -3? Well, no, it's not. So it's not a solution, because if it's not a solution for both, it's not a solution for either. On the next point, we substitute in for the first equation, and yes, 3 is greater than -5. So we substitute it into the next equation, and we find that 1 is less than 3. So that's also true. So we know that's going to be one of the solutions here. So the question is, are any of the following, right? So we have to check them, all of them. On letter C, we substitute in for the first, and we see that it is a yes. And then we substitute it in for the second point, and we see that it's a no, because 7 is not less than 3. So this point is not working for us. On letter D, again, we follow the same path. We substitute in, we see yes for the first, and we see yes to the second. So the 2 ordered pairs that are part of this system are B and D. Don't forget to slow down the video or pause it anytime you're working on something to figure out. So here we have our exponent rules, and on the study guide that you'll have, I have this little note card that I will provide for you guys. So note that you'll have this note card with the exponent rules, right? And so we just have to know how to apply them. So on letter A, everybody in the family gets the power. On letter B, because it's like a set of identical twins, we would need to do box, FOIL, or stack. And then combine the like terms to get our final answer. On letter C, a power to a power is multiplying. And letter D, multiplying powers means to add them. On the next question, number 6, it's the ticket rule, or a negative exponent. A negative exponent is just a ticket to ride. If it's upstairs, it goes downstairs. If it's downstairs, it goes upstairs. On number 7, we're solving again, so we're going to go ahead and use SADMAP to isolate our variable, and we see, we're going to get to e of exponents. So in order to do that, the inverse operation would be to square root both sides. And I can have a decision here to make a simplified radical to see if there's any perfect squares in there, which there is, because 9 times 3 is 27, and 9 is 3 times 3. So we could do plus or minus 3 square root 3, or we could use the calculator and get the decimal and put plus or minus and round that to the nearest tenth. On number 8, what is the degree of this polynomial? Well, first I have to see it in standard form. And we can see that it is because it's going downward in degree by the largest degree first. A 4, a 2, a 1, a none. After that, to know the degree of this polynomial, I would look at the lead. The lead coefficient is 3, but the lead degree is 4. And why do we even care about that? Because that reminds us that in the future, whatever the degree is, that's how many x-intercepts that they'll have in algebra 2. Ours have all been squares, so there have been 2 x's that we've been solving for. Okay, number 9 says to put the equation in point slope. So that means we need to remember what that equation is. The y minus y1 equals slope times x minus x1. When you're given a point and a slope, you substitute in. Then you take care of any simplifying, which a negative is a positive. And then you're done after that. Number 10, we're going to go ahead and classify these polynomials. Right, they're all polynomials, but that first one is actually a trinomial, then a binomial, then a monomial. By 3, by 2, and monomial is 1. 12 and 11 are both factoring, so we factor using Xbox because it's 3 terms. We put that 21 on top, the negative 21 on top, and the positive 4 down below. So we're looking for 2 terms that multiply to be negative 21 and add to be positive 4. If this is a hard concept to you, then you'll notice on Learn that there is a whole slew of videos posted back to chapter 7 about factoring. So make sure you watch those and relearn what you need to know. On 12, oops, sorry, not done yet. So this one I'm only factoring. Get x plus 7x minus 3. 2 numbers that multiply to be negative 21 and add to be 4. On 12, it is a special, and that means that there's some sort of special factoring here because these are opposite twins. And so I know that because x squared is a perfect square and 49 is a perfect square. And it's a difference, meaning one's positive, one's negative. And if you were to box, FOIL, or stack this, you would see it would eliminate the middle term. 13, we're looking to see if this graph has a maximum or minimum. And you could just go, oh, it obviously has a maximum and that maximum is 6. But why do we know that's true? Just to remind you, it's all about the vertex, right? The vertex, the x value is always the axis of symmetry. And the y value tells you whether it's a maximum or minimum because it has the ceiling cap. It stops at 6. It does not go anymore. Where the x values are all real numbers. So obviously in this graph, the vertex shows that 6 is the highest it can go, so it is the maximum. 14, we're looking at completing the square and what we add. Well, we take the b value, the one that's multiplied just by x, not x squared, and it's not alone, and we cut it in half, and we square it, and we add it to both sides. Just one of the many steps in completing the square. On 15, we're going to go ahead and find for the solutions. Now, solutions mean that we use factoring in order to solve. We have to solve when they equal 0. On 16, we're finding the slope. So we have to put it in y equals mx plus b. Once we do that, we can see that the slope is just simply 4. Negative 4, pardon me. Negative 4. Not negative 4x, just negative 4. 17, we're going to go ahead and solve for the systems of equations by eliminating the y value, multiplying the top equation by negative 2. And when I do that, I know I can add these two equations up, eliminating the y values and solving for the x. Once I know the x value, I can substitute it into any of the equations and I can solve for the y value. And the same is true if you decided to solve for x. For y first, you could substitute to solve for x. So our shared solution here is 9, negative 3. Now that we know how to solve for a system, we can take word problems and write a system. So in 18, we're having a clothing sale of sweatshirts that cost $32 and t-shirts that cost $15. A customer is going to buy 7 articles of clothing that include shirts, sweatshirts, and t-shirts. So we know S plus T equals 7. So the first equation's on how many. The second equation's about the money. $32 for sweatshirts, $15 for t-shirts, for a total cost of $156. Now I can choose to eliminate or substitute. I'm going to eliminate, and I chose to eliminate the t-shirts, multiplying the top equation by negative 15, so that when I add these, they would eliminate the t-shirts and I would solve for the sweatshirts. And I find that there's 3. So obviously if there's 3 sweatshirts and a total of 7 items, then there must have been 4 t-shirts sold. Number 19. Number 19 is looking at the slope of this line is negative 5. And so what would be a perpendicular line? Well, a parallel line would be the same slope because they rise and run the same. But a perpendicular would have to be opposite reciprocal in order to cross over and go the right direction. So opposite means from negative to positive, or positive to negative for that matter, and reciprocal is reflipical. So from 5 over 1 to 1 over 5. And number 20, we can see that the equation of the line, which is that y equals mx plus b, we can solve for this a bunch of different ways. But first I'm going to find the slope, and we know the slope is rise over run, or the change in y over the change in x. We can see that the change in x is 1, and the change in y is 5. So our slope has to be 5x. In order to figure out what it goes up by, we have to make sure that this rule or equation works for all the other values here. So if I do 5 times x, I get 5. How do I get to 6? Well, I have to add 1. I can also choose to just find for the y-intercept, so I would subtract and go 1 more step down. And if I did that, I would subtract 5 and I would get 1, right? But either way, whatever I do, I know that this rule has to work for all of these different scenarios. So even if I look at like 5 times 4 is 20, plus 1 is 21, so I know it's right. So always check your solutions, right? Okay, on the next one, we can see that we are subtracting. When we're subtracting here, we always want to make sure we change it to an addition problem so we don't forget to distribute that negative 1. Right, so we could see that we're just going to be distributing a negative 1 to all of these, anything behind here. Or we could just change the middle sign, then we change everything after. Once we do that, we combine our like terms like we did in the Skittles. We match up the color, right? So x squares go with x squares. And whole numbers go with whole numbers. And then we combine and see what we have. And it turns out we have 3x minus 4. Okay, so I had to get rid of some extra writing I had on there. 22 is a reminder of chapter 9, where we are having rational expressions and we are multiplying and dividing these. This is a division, so we're doing keep, change, flip every time we divide anything that's a fraction. So we keep the first and we go ahead and factor it. And the top was the difference of two squares and the bottom was a GCF. We're changing the sign to multiplying and flipping the second and taking out a GCF. And we flip the top down to the bottom. Now we look for any matches to reduce this fraction. And we see if we have x plus 4 is a match and 2x is a match. And as we do with all multiplying fractions, we multiply straight across to see if we can reduce after that. And this one can't, so we're done. On 23, we are evaluating this expression, but we really need to understand our exponent rules to do this well. So 8 has a ticket, so we take it downstairs. X is to the 0 power, so that turns to 1. And y is the value of 2, and it's to the 4th power. Now I'm going to go ahead and reduce this fraction by factoring. I factor out my 2's, getting 2 to the 4th power. And 8, if I was to do prime factorization, 8 is 3 2's, but there's 2 of those, so there's 6 total. I cancel the ones out, and I see this will just lead to 1/4. A lot easier. Or you could have just multiplied it and gotten 16 over 64 and reduced that fraction, but I think this way is easier. On 24, we are writing a proportion, trusting our equivalent fractions here. So this ratio of any item to its shadow is always very consistent because a shadow has the same ratio because it's measured from the sun and what's, the shadow. So for this shadow is a real, height is 42, the shadow is 12. A tree that we don't know the height of has a shadow of 14, and we're going to go ahead and solve for that height of the tree using cross products. Now again, we're not cross multiplying. That is bad vocabulary. That's like fake news. We're not doing that. We've gotten rid of that really bad situation that somebody taught us. It's because they're equal fractions, right? We talked about this first semester. If I have 1/2, we know that's equal to 2/4, right? 1/2 of a pizza is equal to 2/4 of a pizza. We know that's true. And because this is true and it's equal, we can do cross products. 2 times 2 is 4, and 1 times 4 is 4. And that little simple concept means we can use cross products to solve for unknowns, right? Okay, just want to make sure you remember that little journey we took in first semester. So we don't confuse it with cross multiplication, which is just not a thing. And we go ahead and do our cross products here. And we get 12x equals to 588. And then we isolate our variable and we find out that this tree is 49, which makes sense. Because if the shadow is a couple feet bigger than the statue, then the tree has to be bigger than the statue as well, right? All right, 25, vertex is coming back at us again. Our vertex is going to be that negative b over 2a. It's a formula that we have to have memorized, and we know it. And we did a lab for this. Then we know our a, b, and c, right? Because a is at the beginning, and b, it's always alphabetical, you guys. And then you have, change colors here, c. Right? A, B, C. So then I do negative B, negative 24 over 2 times A, and this A happens to be negative 3. So I get negative 24 over negative 6, and that's how I get this 4. And that's my X value, or my axis of symmetry. Then I have to substitute in order to solve for the Y value. I know it's Y value because it says Y equals to all this. Right? So I know I can put that in. Let me just clean this up a little bit so it's easier to read. And I solve because it says y equals, and everywhere there's an x, I put this new x in here. So I can solve for that and I get 26. At that point, it's PEMDAS, and we just have to make sure we're not making mistakes with our negatives or our variables. Okay, 26 is products. If I'm doing a product of a binomial, I use box, FOIL, or stack. We want to make sure we remember this. We box it out. Then we multiply those monomials and we combine like terms. On 27, we're just simply writing the equation of the line here because we know our rise over run and we know our y-intercepts. So we can just put that in the correct order there. Okay, we are graphing this inequality. We always start with our y-intercept. That y-intercept is -3. And then we do our slope, and our slope is up 2 and over 1. And I always like to put a couple in here. And then I need to look at whether it's going to be a solid line or a dashed line. And because it says it's less than, I know that it cannot be a solid line, right? Now I could start with a solid line, but I have to remember to erase and get those little dashes in there because it is a dashed line, it's not solid. And now I need to see which side I'm going to choose to shade to show all the solutions, right? And it says y is less than 3. So numbers that are less than 3 on the y-axis are down here, right? So I know I'm going to be shading this direction because those contain the numbers that are less than -3. All right, with our last question that we're going to go through today, we're going to graph this. And to start graphing a parabola, we always start with the vertex. You hear that a lot. So then I go ahead and find my vertex using -b over 2a. I substitute in to solve for my y value. And now, honestly, you could, if you had a really easy one, you could use x-intercepts, right? Do you have two numbers that multiply to be 2 and add to be 4? That's not actually a thing. So we will go ahead and substitute in points. Points that are bigger, -1 and 0. And I put 0 in first because it's always super easy to solve for that, right? So I substitute into the y equals. If it's 0, this goes away, and it's 2. That's how I get 2 and 2 mirrors over here, right? And I can graph with just 3 points and it'll show where I'm going. And that way when I solve for my other 2 missing points, I can double check and make sure they're on my graph, right? So I go ahead and solve for -1 and I solve, and that one mirrors. And I go ahead and check those points and they work. Okay, so what else can you do to study for this? Chapter 9 study guide, which is after this. The video is already posted. And then on Learn, I have posted 6, 7, 8, and 9, the playlists. So not only are the study guides on there, but all the individual concepts. So if you find a concept like factoring, right, then go to chapter 7 and see which part of the factoring you didn't get. If you're struggling with completing the square, right, if completing the square is your problem, then you're going to go to chapter 8 and you're going to find that around 8:6 to 8:7, and you're going to look at those videos and you're going to complete the square and practice. There's also your textbook. Your textbook is a great thing. Textbook is always nice to see. Go check out all these chapters, right? And of course, lastly, tomorrow on Friday, our Zoom time is 10 to 11:30. Come check that out. Right? If you have any last minute questions, things you want me to go over. And then one last thing I want to show you again is this, is the note card that I made for you. On here we have the different exponent rules, the vertex, reminder of factoring, Xbox, how to evaluate is PEMDAS, how to solve is SADMEP, how to make our t-table, point slope form, slope intercept form, inequalities, right? You just can't go wrong. I'm sure you're going to do great. And I can't wait to see you next week to ace the final and move on to have a lovely summer. And again, I'm always happy to pray for you or to hang out. Take care.